And so now that we have this, it's time to do the coding. And so if you're not familiar with any coding or development, that wouldn't be a problem. You know, I don't come from a coding background, but through a little bit of research and everything, I was able to come up with a way that allows me to create basic code for functionality, much like this. And so what we'll do is we'll go to our assets, we'll right click, we'll create a folder, and we'll call that scripts. Again, you don't have to call it scripts. You could call it anything else. You could call it codes. You could call it whatever you want to do. But this is just to keep you organized. We'll we'll double click inside of it. We'll right click. We'll create C# script. And so C# is the coding language that we're going to be using for this. And so before you do anything, when it gets to this point where it says name your script, it's important that you name your script. And you name it a specific name. You can't just name it anything. You have to name it specifically, because this allows the code to really build the experience with it. It doesn't. You could name it anything, but it has to be consistent. And so I'll say this is scale script. Oops. So I'll say this is scale script. And so when I click on it, you'll notice how it says scale script here, and it matches the same name. Just as a tester, I'll show you if I do create new script and I say this is just new script behavior, and then I want to change it. So I'll say scale script 1. When I change it, notice how it still says new behavior script. So you want to make sure that the public class new behavior, the public class script name is the same as the script name that you have here. If it's not, it's best to just go ahead and delete it. So right click, delete. Let's go ahead and delete that, so that and then just create a new one. And make sure that it is scale script right here. And scale script right here. Okay, so now that we have our environment set up, it's time to actually get into the coding. So we'll just double click scale script. And we will go through and we will start making our script. So the first thing that we need to do is, because we have UI elements, the next thing you can do is add a namespace called UI, essentially. And so in order to add a namespace, and this is like the namespace is essentially the library or the dictionary that Unity uses to look for certain functions that you're trying to call. And so you go by using Unity engine, and then we'll click .ui and make sure it's capital letters, and then we'll add a semicolon. And a semicolon sort of closes that statement and allows Unity to say, okay, I want to, using the Unity engine, I want to look at the UI chapter of the library or the book and pull from that information there. The next thing that we'll do is, for me, I like to add 3 spaces. And so after the scale script mono behavior and this bracket, I like to add 3 spaces, and then I'll click tab in the middle space to give me a nice little formatting behavior or formatting environment. And so from there, I'll go through and say public capital SLIDER, and this is one of the things that the using Unity engine UI allows me to call on the slider function and referencing a slider. And then I'll click space, and then I'll just name it slider. I'll just name it scale slider. and then a semicolon. And so what I like to, and you'll notice that this turned green. It might be a different color on yours. I'm using a different version of, I'm using Visual Studio Code. But if you're using Visual Studio Community, it will have a different color, but there will be a certain color there that's consistent across these. And that just means that these are speaking the same language. So we're using the word public because we want this to be an accessible variable. And because we're using minimal code, you essentially have public available so that you get drag and drop stuff in. And so it just makes things a whole lot easier. You can hear things about private and other sort of words that you could use here, and those mean different things. But for this, it's all about creating accessibility within the Unity interface and not using a lot of code in general. And so with this, you would have a lowercase for the first word and then an uppercase for the second word. And it all sort of sorts itself out. This is all like code magic and Unity magic that for non-coders, it's fun to learn, but you don't necessarily have to learn this stuff. And so with this, you could get rid of the void start because we won't need that. And this is void start only calls upon something once when you start the app. And with the slider, we want to make sure that we can call it once per frame, or we want to make sure that we're able to call it multiple times. And so void update will always look at this slider variable and say, if it changed, we'll change it. If it didn't change, we'll stay the same. And that's what the update is. And so when it says update is called once per frame, that just means that whether it's going at 30 frames per second, 24 frames per second, 60 frames per second, you're going to update this every frame. If it doesn't change from one frame to the next, then it won't get updated. But if it does, then it will give you the effect of, real-time movement. And so from there, this is where the coding starts. So we have the environment. Now time to put the words and the code together. So what we'll start off with is, because we want this to scale, this is a transform function. And so we'll actually add transform. And so once we add and we acknowledge that it's a transform function, we want it to scale in a certain direction. And so in order to do that, we want to call upon the feature local scale, because we don't want to scale everything. We just want to scale the specific thing that is attached to the slider. And so we'll do local scale, and scale is with a capital letter. And so that sets up our environment. And so we'll go equals, and from there we'll say new capital VECTOR vector3. And so all that means is that based on the local scale that we have, a new vector3, or when we're talking about if we have any physics people, so there's three vectors. There's the horizontal, vertical, and depth. And so when we're talking about scaling, we want to affect all three vectors, all three directions. We want to affect the X, the Y, and the Z all at the same time. And so when it updates, even though the original model has a specific vector quantity associated with it, with the new vector, it's going to update that to the new quantity based on the scale transform. And so we'll have some brackets, so we'll have some parentheses, and then we'll call upon our scale slider. So scale slider, and we'll say that it's going to be our value from the scale slider. And so typically the way it works is we have X, Y, and Z. And so we want to, and that's how it's quantified. So vector 1 is X, vector 2 is Y, and vector 3 is Z. And so we're calling upon all three of these vectors to change with a specific value that comes from the slider scale. And so what we're going to do is we're just actually going to make sure that all of those are the same value. And so we'll just do a comma. We'll do scale slider dot value. Do another comma. And then last but not least, scale slider dot value. And then at the end, we'll do a semicolon. And so we have our X, our Y, and our Z values. And those values are going to be the same values that we have for here. And we'll just delete that. And we will click save. So one thing to note is that you want to make sure that this is the same as this, this, and this. If one of these are different, then it's going to give you a bunch of errors. And so we have this saved. We'll go ahead and we'll go back to Unity. It will update. Once it updates, you could check it with our console. If there's anything red, that means that there were problems. Now that we have that, we'll actually make another script. So we'll get both of our scripts done right now, and then we'll start to set it up with actual AR experience. And so next thing we'll do is we'll go to create. We'll go to C# script, and we'll name this one rotate script. So now that we have rotate script, again, we'll double click. Now it creates the same thing. And what we're going to do is we're going to do the same thing that we did before. So using Unity engine dot UI semicolon. Since it's still a slider, we'll use the same sort of approach. Again, we'll make 3 spaces. We'll do tab, and then we'll say public. Then we'll do slider with a capital S, and then this time it will be rotate slider. So ROTATE SLIDER. And the slider part, the S in slider is going to be capitalized. We don't need the start function. We'll just need the update function. And this time, this is where it gets interesting, because normally you would say, okay, we want for the transform and the rotation, we want it to be similar to the transform of the scale, where with scale it was local scale. With rotation, it's not going to be local rotation, it's going to be local Euler angle. And the local Euler angle just says that in a particular point locally, it's going to have a specific angle value, and that angle value is relative to where it's starting at, and not necessarily the overall rotation of it in the real world. And so all it's saying is that if the model starts at a angle of 0 within that rotation, we're going to rotate it to another angle from angle 0. And so what that looks like is we're going to do transform dot local, and then it's going to be a capital EULER, capital ANGLES, Euler angles. Here we go, equals, and then back to the regular stuff, new vector 3, and then we have our parentheses. So we typically have X, Y, and Z, and then we'll have our semicolon to sort of make that statement. So with it, we only want it to rotate around the Y-axis. And so if we don't want it to rotate around the X-axis, we just add 0. If we don't want it to rotate around the Z-axis, we add a 0. And if we want the slider to dictate what that angle is, we want to make sure that it's referencing the slider value. So we'll go to rotation or my fault. Rotate, capital SLIDER for slider, and then that's just going to be value. Oops. Value. And so now what it looks like is we have the transform in the rotation, which is the Euler angle, and then that's going to create a new vector 3 or a new value for the app to update, and that's going to be based on the rotate slider. And so as you change the slider, it's going to change the model that the slider is connected to. So we'll just go ahead, click save, and that is all the code that we need. That is all the code. That is it. And so we'll just go ahead, exit that, wait for it to update. There's no errors. And so now we can move on to actually implementing the code within our project.